Hey guys, so now we're gonna do application problems and dot product. So I'm just gonna go over working these two problems as well as the dot product. It's gonna be pretty easy going down here. This is gonna be a little bit more. So I'm gonna try to explain it pretty well. So forces with magnitudes of 2,000 newtons and 900 newtons act on a machine part at angles of 30 degrees and negative 45 degrees respectively. Now the word respectively means it goes in that order. So the 2,000 newtons, which came first, goes with the 30 degrees, and the 900 newtons goes with the negative 45 degrees, okay? Find the direction and magnitude of the resultant of these forces. All right, so we're gonna end up combining the forces and finding the direction and magnitude of them combined. All right, so the first thing we're gonna do is find the direction of each one independently. We've been given the magnitudes of each one. Now we have to find direction, which is going to look like this here. And I've taken these formulas from previous sheets where the formulas are listed. I just don't want to have to flip back and forth, and it's probably best if you pause and write this stuff down as well. So if I am looking at it here, and I like to draw a picture because it just kind of makes sense. So we have 2,000 newtons at 30 degrees. That's going to be somewhere around here. I'm going to go ahead and label this as 2,000 newtons. And then we have negative 45 degrees. And what is this? 900 newtons. All right, so the direction is going to be shown as the magnitude times cosine of that angle, comma, magnitude times sine of that angle. So let's start with the first one, and we'll just label U as the first one. So that's going to be the magnitude, which is 2,000 times cosine of 30, comma, 2,000 sine of 30. All right, and then we have V, which is going to be 900 cosine of negative 45, 900, sine of negative 45. All right, once we put these in the calculator, we'll get some numbers and we'll put them here. So we have 1732.051, comma, 1,000. All right, and then we have 636.396, comma, negative 636.396. All right, so because we are finding the resultant of these forces, this is our direction for the first force. This is the direction of the second force, so we're going to combine them by adding them together. All right, and that's going to give us RU plus V. Okay, so once we add them together, we will get 2,368.447. And I will recommend putting these into your calculator and checking them. You want to make sure that, number one, your calculator is in degrees and that you are getting the same answers, and that's just making sure that you're going through the steps correctly. So please make sure that you're doing that. 0.604. Okay, so now this gives us our V1 and our V2, our combined V1 and V2. So I'm just labeling that because we have to find the combined magnitude. This is their combined direction. All right, so now we have to find their magnitude, which is going to be the square root of V1 squared plus V2 squared. So that's going to look like 2,368.447 squared plus 363.604 squared. All right, and then once you put this in the calculator, you get a combined magnitude of 2,396.195. All right, so that's our combined magnitude, and this is the direction combined, and that's the first one. So moving on to the second one. All right, a ball is thrown with an initial velocity of 80 feet per second at an angle of 33 degrees with the horizontal. All right, 33 degrees. And I didn't necessarily need to label these, but it definitely helps picturing wise. We have 80 feet per second. Find the vertical and horizontal components. So we're actually going to use the same, it's the same as the direction down up here, but I've just moved it down here because horizontal, so the x is equal to the magnitude times cosine theta, cosine of the degree measure. So if the x is 80, cosine 33, y is 80 sine of 33. And if you guys remember from the unit circle, cosine represents x, sine represents y, so that should help you with knowing, but you'll always have access to your formulas. Once we put that into the calculator, we get 67.094, comma 43.571, and that is going to be our answer. All right, on to dot product. I think you guys are going to like this a lot. So in general, if V equals V1, V2, and U equals U1, U2, the dot product is shown. It is V1 times U1 plus V2 times U2. And I'm going to work a little example here. I'm going to go ahead and label these as V1, V2, U1, U2. Find the dot product. So V times U is going to equal to V1 times U1. So I'm going to find V1, 2 times -3, which is U1, plus V2, which is 5, times U2. Oh, that's confusing. U2, which is 2. All right. We have -6 plus 10, which gives us a +4. And that is how you find dot product. All right.